So, we're going to be factoring to solve quadratics. Okay. What we mean by solving quadratics is we're going to isolate to find possible answers for x. Okay. So, what we're going to be doing is we're going to be setting, first off, we're going to be setting our y variable equal to 0. And when we do that, if we're on a graph, what part of a graph are we on when y is equal to 0? Anyone remember? Y is 0. What part of the graph are we touching? What do you mean by the middle? What's this called? No. What is it, Terrence? X-axis. Very good. So if we're solving for when y is 0, that means we are on the x-axis. Okay? So we're looking for, with many quadratics, 2 points. Maybe it looks like this. Maybe it's facing downwards. But we're probably going to end up with 2 answers. There's a possibility of 2 answers, 1 answer, or no answers. For what we're doing today, we're going to be looking for questions that have 2 answers to them. And we're going to be doing this by factoring. So the very first step we're going to be doing is setting y equal to 0, which means we're going to replace the y variable with 0. And then we'll have the rest of the equation. Negative 3x squared minus 24x minus 45. Okay. What we're going to be doing is we're going to factor to solve. Now, very first step to factoring. Anyone remember what type of factoring we do? Common factoring. Good. Anybody see a common factor we can take out of these? 1? Yeah, we can take something out that larger out. 3. Good. And not just 3. When we factor, we usually want to be working with our first term to be positive. So we're going to take out a negative 3. In other words, we're going to divide all 3 of the terms by negative 3. That negative 3 won't disappear. And now comes to the front of our equation. So we have negative 3. And then we're going to set up a bracket with whatever would be left in our equation. So what would negative 3x squared divided by negative 3 be? X squared, good. Negative 24x divided by negative 3? Positive 8x, yeah. And negative 45 divided by negative 3? Positive 15, excellent. Okay, so we've taken a common factor out to start. The next step is we want to actually factor our bracket. When we're factoring our brackets, we look for the factors of the first term. And what would the factors of x squared be? Yeah, so 1x and 1x. And we look for factors of what else? The 15, in other words, the last term, or c if it's in standard form, right? What are factors of 15? Yeah, any others? Good. Okay. So we're going to go through this slowly because I know it's been a while since we've gone through factoring. We're going to set these up into columns, okay? And we know that our red column is going to deal with the first terms when we factor, and our green columns are going to deal with our second terms when we factor. Now we know we need one of each, a green and a red column. And we know that we're going to be multiplying these two together to add up to what term? That's right, the positive 8x, the b, the middle term. So we have our 8x. Oh, thank you, that's good. The other one. Okay. So, when we do that, we're going to have to go by trial and error. Now, it's pretty obvious by looking at this, but just to go through the motions so you guys remember, we do got to test each of the columns we've made. So 1x by 1 and 1x by 15 will give us 1x and 15x. Do any combination of those two add up to 8x? No. And, of course, we go diagonally. Is that going to change anything? We're still going to get 1x and 15x. So we know the 1 and the 15 don't work for what we're doing. We can kind of cancel them out. So we're going for hopes here that 1x times 3 and 1x times 5. That would give us 3x and 5x. Do they add up to 8x? Yep. And do positive 3 and positive 5 multiply to positive 15? Yes. Good. So both of our checks work. We know that that works. So now we can include the rest of the equation. We have 0 is equal to, we still have that negative 3, don't forget that. And then we set up our two brackets. We know that our first terms are going to be 1x and 1x, or just x and x. And our second terms are going to be positive 3 and positive 5. Now, technically, let's say this was the 1x we put in this column here. Because we multiplied this 1x by this positive 3, they need to go in opposite columns. So we're going to put the positive 3 in this column. And then the same idea is with our 1x that we put in this column and the positive 5. Because we multiplied those two together, they have to go in opposite columns, so the positive 5 goes over here. Okay? Now, I know I'm recapping factoring, and I did this on purpose because I know it's been a little bit since we've done this, but you need to be pretty proficient with this in order to get to the next part of the question. Okay, guys? Okay. So, we've now factored. We've gone from standard form to factored form, and what we're trying to do is solve for values of x. In that case, what we want to do is we want to make sure that we have just the two brackets left. Okay, we're trying to isolate these two brackets. So right now we have a -3 attached to the outside. What operation does this -3 have with this bracket between them? Multiplication. So do we kind of want to move this -3 to the other side? What would I do to each side in order to do that? That's good. So let's divide this side by 3 and this side by -3. What happens to the two -3's on the right? Excellent. They cancel out. And 0 divided -3? 0. Still 0, okay? So you're going to notice that when you common factor, essentially you're going to be able to drop off that common factor as long as it's just a number and there's no variable attached to it. Okay? So we're now left with these two brackets. These two brackets need to multiply by each other to get 0. What is the only term you can multiply by to get 0? 0. So in other words, one or both of these brackets need to be 0 in this case. So we're going to test for each of them. In other words, what we're going to do is from this point, we're going to split the question. We are going to set x plus 5 equal to 0. That's one bracket. And we're going to set x plus 3 equal to 0. Okay? That's the other bracket. We're then going to isolate for x on both of these. So when I move positive 5 to the other side, what does it become? So we have x is equal to -5. And on this side, when we move 3 over, what do we get? X is equal to -3. So remember I told you we're going to be solving for 2 points? Those are the x-intercepts. So we're going to draw a rough sketch of a graph here. And what those tell us is that this parabola at -3, so we'll call this point -3, and this point -5. The parabola, or the quadratic, crosses those at that point. Now let's go back up, because there is a little more information we get from this. The a value is positive or negative? So which way does this parabola open, up or down? Down, good. I'm glad you remember that. So in other words, we have some parabola that crosses this point, comes back down, and crosses that other point. The two x-intercepts are -5 and -3. Okay? We factor to solve these, so let's kind of take a bigger picture look here. So, those steps again. We first common factored and took out -3. We then factored our two brackets. Once those are factored, we get them by themselves, and we set each bracket equal to 0. When we do that, we isolate for x, and we get two answers, -5 and -3. And those are the two possibilities that would work here. Okay? So we're starting to learn about, in linear equations, we only had one possible answer. When we do with quadratics, we could have two possible answers. So when they tell us to solve by factoring, we're solving for, at max, 2 answers right now. Oops, wrong one.